All right, in this video, we are going to talk about the multiplication rule and the concept of independence. All right, so first off, we are going to start off with the general multiplication rule. The general multiplication rule tells you how to find the probability of the and of two events. So if A and B are two events, then the probability of A and B is equal to the probability of A times the probability that B occurs given that A has occurred. Okay, so that is the general multiplication rule. That works for any two events, A and B, to calculate the probability of A and B if you can determine what these probabilities are, right? So let's take a look at an example. All right, so this is problem 4.180 from our book, Addiction Medicine. The report, Addiction Medicine, Closing the Gap Between Science and Practice, from the National Center of Addiction and Substance Abuse at Columbia University, reveals that addiction treatment is neglected by the medical system in the United States. It shows in particular that 16% of Americans have the disease of addiction and that 90% of them receive no form of treatment. Okay? And what they're asking us to do is to determine the probability that a randomly selected American has the disease of addiction and receives no form of treatment. Okay? All right. So, first off, I'm going to let A be the event that a randomly selected American has the disease of addiction. And then I'm going to let N be the event that a randomly selected American receives no treatment. All right, so what the problem wants us to do is to find the probability of A and N. Okay, so going by the general multiplication rule right here, right, we're using this and applying that to this problem. We have the probability of A and N is the probability of A times the probability of N given A. Okay, so first off, the probability of A, that is the probability that a randomly selected American has the disease of addiction. So if we go back and look at the problem, it says, in particular, 16% of Americans have the disease of addiction, right? So if we randomly select an American, right, the probability that that person would have the disease of addiction is 16%. So that's why we have this 0.16 right here. That's the probability of A. Then looking at the other probability that we want, the conditional probability, we want the probability that a randomly selected person receives no treatment given that they are suffering from the disease of addiction. Okay, and if we go back and look at the statement of the problem, right, it says it basically tells us that right there. It says 90% of those Americans who are addicted receive no form of treatment. So, in other words, if I randomly select an American who suffers from the disease of addiction, the probability is 90% that, or 0.9, that they receive no form of treatment. All right, and so that's this conditional probability right here. So basically, they just told us the two probabilities that we needed, and then we would multiply those out, and we get 0.144. Okay. They wanted us to interpret that in terms of percentages, right? So basically what that says is that 14.4% of Americans have the disease of addiction and receive no form of treatment. Okay, so that's the probability of A and N. All right, so that's how you would go about using the general multiplication rule. All right, let's take a look at another example. In this example, it says cards numbered 1 through 10 are placed in a box. The box is shaken, and a blindfolded person selects 2 successive cards without replacement. So they pick one card, look at the number on it, and then they set that card off to the side. Then they reach into the box and pick another card, right, and see what the number on that is. All right. Okay, so what they want to know in part A is what is the probability that the first card selected is numbered 6, right? So at that point, there are 10 cards, right, in there, and there's only one of those cards that are numbered 6, right? And so the probability is 1/10 that the first card is a 6, okay? All right, in part B, it says, given that the first card is numbered 6, what is the probability that the second is numbered 9? So they want to know what is the probability that the second card drawn is a 9, given that the first card is a 6, right? And so that would be this probability here. What is the probability that the second card is a 9, right? Given that the first is a 6. All right, so in this case, what we're just going to do is imagine that the first draw has already been made, okay? So the first draw is made, and that card is a 6, right? And then that card has been laid off to the side, and now there are only 9 cards in the box left, right? Because this is done without replacement. So our sample space now for this second part, right, is 9. There's 9 cards. So those are the 9 possibilities on the second draw. And one of those cards is a 1. I mean, a 9, rather. Right? So there's one way that you can get a 9 on the second draw. So the probability would be 1/9. So again, we assume that this event has happened already. Okay? And then we calculate the probability of this other event here, assuming that that's happened. All right, let's take a look at part C. All right, in part C it says find the probability of selecting first a 6 and then a 9. All right, so we want the probability that the first is 6 and the probability that the second is a 9. All right, so using the general multiplication rule, that would be equal to the probability that the first one is a 6 times the probability that the second one is a 9 given that the first one is a 6. All right, so we are just using that conditional probability rule, or the general multiplication rule, rather, right? And actually, these are the numbers, these are the probabilities that we calculated in part A. In part A, we calculated this probability as 1/10. Right? In part B, we calculated this probability as 1/9. Right? So altogether, that's going to be 1/90 on part C. Okay. And then let's do part D. In part D, they want to know what is the probability that both cards are numbered over 5. So we want to know probability that both are greater than 5. All right, so what you need to do is the way they worded this in English, it doesn't involve one of these directly. It doesn't look like it involves one of these operators that we talked about, not, or and, but in fact it does, right? It's just in English you can word things slightly differently, but that doesn't really help you figure out what rule to use when we're talking about probability. So what we want to do is to phrase this event that they're both greater than 5 in terms of the and operator here, right? If they're both greater than 5, another way of saying that using and, right, is that the first one is greater than 5 and the second one is greater than 5. Okay, and so that is more desirable than this, right? And because we have a nice rule that lets us calculate this probability, the general multiplication rule. All right, so we know by using the general multiplication rule, that's the probability that the first card is greater than 5 times the probability that the second card is greater than 5 given that the first card is greater than 5. Okay, and so now we would just calculate these probabilities. So first is that the probability that the first card drawn is greater than 5. At that point, right on the first draw, we have 10 cards in there. And the ones that are greater than 5, we have 5 of those, right? 6, 7, 8, 9, and 10, right? So there's 5 cards in the box with numbers bigger than 5. Okay, so 5 out of 10. All right, next up, right, we're calculating the conditional probability, right? We want to know what's the probability that the second card is greater than 5, given that the first card has been drawn and is greater than a 5. So at that point, right, if the first card's been drawn and it had a number bigger than 5 on it, we set it aside, right? So now the sample space, there's only 9 possible outcomes for the second draw, right? Because there's only 9 cards in the box. And then, right, assuming that we're given that on the first draw we drew out a card with a number bigger than 5, now there are only 4 numbers in the box, 4 cards in the box with numbers bigger than 5, right? Because one of them got drawn in the first. We don't know what that is, but we know there's got to be 4 left in there, okay? And so that's it on that one. So you wind up with 20 over 90, or 2/9, right, for that probability. All right, and that is it for 4.182. All right, I think we are going to stop there, and we will, in a separate video, work this problem 4.184.